Okay, so let's see MLPs in work. In the last video, we had seen a simple artificial neural network. Actually, we had seen just a single neuron. Now, let's see multiple such neurons and how they work, how machine learning actually works. So, what we have done here is we have copied some code from GitHub, and now we are initializing some inputs. These are 3 inputs, and that is why when you'll see this, when I have initialized a machine multi-layer perceptron, we have 3 inputs, these 3 inputs, 2 hidden layers, each having 4 nodes and 1 output neuron. When I call n of input, these inputs get fed in the multi-layer perceptron. So we get this random value, and we would have gotten any other value if we run this again. So now what I'm doing is I'm doing the same thing, but instead of just one single input, I'll be giving 4 inputs, each having 3 individual inputs, and each of this will be fed in the MLP, and each one should produce our target outputs. Now at first it won't produce any sort of output. First I'll run this, and then I'll run this. Yeah, so what we are getting is the predictions predicted by our MLP. Now this is a untrained MLP, so the prediction that it is producing is not at all close to the actual outputs that we want it to. So now what we'll do is we'll train this ANN. What we'll do is we'll create a loss function. I'll show you how to create a loss function. First we'll run a for loop for y comma y hat in zip of ypred comma output, and we'll square this up, square the difference between them, y minus y hat, it's squared, and we'll sum it up, sum of this entire thing. So the predictions produced by our machine learning MLP will be subtracted from each of the outputs, then squared, and the sum will be the loss. We'll print loss, and we get a very high loss, 5.10 whatever. So this is a very high loss. What we'll do is we'll now optimize our, we'll improve our multi-layer perceptron. What we'll do is we'll do loss.backwards. You should know what backwards does if you have watched my previous video. If you haven't, you can watch it by clicking on the link present below the like button. First, this loss.backwards will be called. Then we'll do for p in n dot parameters, and we'll do p dot data. What is this? P dot data minus equal to p 0.1 times p of gradient, and p of gradient will be set back to 0. Now what I've done here is I've called loss.backwards. Loss.backwards will set the gradients for each of the nodes. Then for each of the nodes we'll subtract its gradient by a tiny amount, and then set the gradients back to 0, so that in the next call the gradients can be set fresh. So this is the forward pass, this is the loss calculation, and this is the backward pass, we'll call it. And okay, so what we'll do is we'll note down the loss. This was the initial loss, this is the new prediction. When we calculate the loss, we should see some improvements. So so the loss has considerably improved in one single iteration. So this is the forward pass, loss calculation, and backward pass. Forward pass, loss calculation, and backward pass. We'll repeat this step, and exactly for this I have created a for loop. We are executing the same function here, but inside a for loop, so that the repetitive process can be executed in one go. We'll add this, we'll print the loss, which should be very small. Okay, the loss hasn't reduced, and this might be, the loss has reduced a lot. It has reduced a lot. And if we do ypred, we came from here 0.2 minus 0.51 random outputs, and we wanted this was our target output, 1 minus 1 minus 1 and 1. So what we should see is should be much better than this. We'll print ypred, and oh my god, yeah. So this is kind of exactly what our MLP has learned. We went from this random outputs, random predictions, to being very close to 1, minus 1, and 1. See, 1, this is almost 1, this is minus 1, this is minus 1, and this is 1. So this is exactly the point of the video. This is how the internal mechanism of machine learning or multi-layer perceptrons work. First, there is forward pass. Where we predict the outputs given by our multi-layer perceptron or machine learning model. Then we calculate the loss. Then we call loss dot backwards, and we change each of the nodes data, or rather weights data, by a tiny amount of its gradient. And we came from this loss to this very tiny loss. This is almost negligible loss. And what I've done here is I have basically called this for 1000 epochs. This epochs term you'll notice in professional machine learning projects. And this is it.